Hello and welcome again. Thank you so much for staying tuned. Thank you for liking the videos, the sharing and subscribing. Thank you for following. Now we already started Surds and we looked at distance. Previously we looked at definition of surds, looked at irrational numbers, and we also looked at basic forms. The last class we looked at transformation of basic forms. In other words, you can transform from basic surds to another form back to basic surds. Now, I now give this as an assignment, in which case I did two examples and I said do this. Now, you want to go back to previous video, go back to my previous videos, just click on the page name. You'll see take you to my profile, and then you look at the previous videos. You see how I've solved these things. And just again, you can subscribe, like, and follow. Now let's see how we did this in the past class. So we are now transforming, that's converting, taking back to basic form. So what does this mean? This one originally, we'll have to put it in such a way that this 11 that doesn't seem to be under a square root sign will also be under a square root sign, in which case it's going to be a single number, actually then multiplied, a single number will now come in under the square root sign. Now, for us to obtain this, when we move from basic numbers, basic form to this place, to this transformed position, what we did was to look for the level of the square root of a number that gave us 11. So what's the opposite? If I did the square root of a number to obtain 11, how do I go back to that number? What I should do is to do the opposite of square root, and the opposite of square root is square. Square takes it up, square root brings it down. Like the root of a plant. The root of a plant is ground, a ground. So the square takes it up, and you also see square written on top of it as a superscript. Now it's going to be, now this particular statement is still the same thing as writing it this way. 11 times, have I spoiled mass? No, it's still the same thing. Now this one was actually squared, so this is going to be 11 squared times 2. And by the time, now what is it? 11 is the same thing as doing the two operation on it, the two opposite operation, because the two opposite operation will still bring it down to this. So 11 is same as doing 11 squared. In square root of 11 squared, or 11 squared, the square root of it, the square root of 11 squared. So I'm doing the two operations on it. So you see here it was just 11, and we're having 11 and the square of it, and then the square root of it. So this 11 is the same thing as 11 square root and squared. So what does that mean? In this place now, but we're not going to do the square root of square root. What we'll just do is okay, fine. If this is the case, what is 11 squared? 11 squared is 11 times 11. So what's 11 times 11? 11 times 11. 1 times 1, 1, 1 times 1, 1, 1 times 1 is 1, 1 times 1 is 1. Add 1 to 1. Simple. I've known it before, but I need to do it for some people who, or if at least there's one person who doesn't know how to do that. So 11 times 11, or just on that. So we say, how did you get this? So this is going to be 11 squared is 11 times 11. So it's going to be 1 to 1. Remember, I've only done squared, and the square root sign is still there. So this times 2. Our goal is to make sure that we have a single number that is under the square root sign. So we'll bring the two square roots. Since there's square root sign, there's a square root sign here. Square root sign, let's use 1 for the 2 of them. So it's going to be 1 to 1 times 2. Right? So bring it to the basic form, which is the final answer. It's going to be 2, 1 to 1. What's 1 to 1 times 2? 2 times 1 is 2, 2 times 2 is 4, 2 times 1, 2. So you have the square root of 242. In other words, the square root of 242 is what gives us this. And this, the basic form of it, is this. So that's what we have. So you want to go back to the previous class, and then you know how we got to this place. Now today I have written 2 questions up, so we'll get to go into a new part of it. we're looking today at similar surds. Now, what are similar surds? Similar surds are surds which are a multiple of another surd. So, surds which are a multiple of another surd. For example, now we can have, let me share an example. We can have, like you have 2 raised to the power of 2 and 3 raised to the power of, 2 square root 2, 3 square root 3, 4 square root 4. It doesn't have to follow sequence. 4 square root 2, it can be any other number. Let's say it doesn't have to be 4. Let's say 6 square root 2. It can be even 8 square root 2, for example, and so on. Right? Now the thing is this: each one of them have square root of 2 under them. So if I bring them to this, they are similar surds. They have a similar base of square root of 2. Now let's bring this one: 2 root 2 and 3 root 2 and 4 root 2 and 6 root 2 and 8 root 2. I've just decided to use this as an example. So what is 2 root 2 from what we've done here? How do we convert it to this number part? It is the same thing as saying they are similar because they all have the same square root size. So this outer part, the whole number changes. So there we have 2. The same thing as saying 2 times square root of 2, which is, this one was originally the square root of 2 raised to the power 2 times square root of 2. So this is what? This is going to be the square root of what? 4 times 2 is going to go 8. So this is what? So in other words, I'll just say 3 times 3, 9 times 2. 3 times 3, 9 times 2, 18. So this is 18 squared. And this is 4 times 4, 16 times 2, 32. And then that's to avoid going this way. A time will come in maths where you can easily jump steps. At certain level, don't jump step. It may not be okay. At some point, or if you gain mastery of a particular part, you can jump the step in order to save time, especially on in exam condition. But don't do it anyhow, flippantly, so you don't lose marks. So you have this to be 6 times 6, 12 times 2. Then 12 times 2 is 20. 6 times 6, 36 times 2 times 2. This 2, this is 6 plus 1, 72. So you have 72. The square root of 72. Now this can be transformed in the same way. Now I want to leave you with the same assignment. Convert this to this pattern. Convert to this pattern and let's see what happens. I have not given much assignment, or I may just include another one. I may include 1 here, 12, 2. Convert it just to this 2 as assignment. Let's meet in the next class for the length of the video. Thank you so much for staying. Thank you for liking and sharing. You want to get more, please stay tuned. The next class will be soon. Thank you. Bye.